Hello my dear students, welcome to Teacher at Home. Today class we are going to learn the first chapter, Sun, the Ultimate Source. Look at the above maps showing the atmospheric temperature of a few cities in India. Is the temperature the same at different places on the same day? Is the temperature experienced at a particular place the same in all seasons? You might have understood that the temperature varies in accordance with place and time. Let us look at the causes and consequences of the varied distribution at atmospheric temperature. You know that Sun is the sole source of energy for Earth. Solar energy receives the Earth in the form of short waves. It is called insolation. So, the solar energy reaching the Earth in the form of waves is known as insolation. The Earth's surface facing the Sun gets heated by this flow of energy, which begins with sunrise and lasts till sunset. The heat is then transferred to the atmosphere from the surface of the Earth through various processes. Process of heat transfer in the atmosphere. The given diagram shows conduction. Heat is transferred to the part of the atmosphere close to the hot surface of the Earth. Convection. Heat air expands and rises up. Advection. Horizontal transfer of heat by wind. Terrestrial radiation. Heat is transferred from the surface of the Earth to the outer space in the form of long waves. Conduction, convection, advection are confined to the near atmosphere of the Earth. The re-radiation of energy from the surface of the Earth back to the outer space in the form of long waves is called terrestrial radiation. Atmosphere absorbs the terrestrial radiation. We have studied in earlier classes that some gases present in the atmosphere can absorb terrestrial radiation. Now you might have understood that the atmosphere is heated mainly by terrestrial radiation. Heat budget. As you know, the term budget implies a balance between the income and expenditure. Similarly, the balance between insolation and terrestrial radiation is called the heat budget. Look at the picture. If we consider the total amount of insolation reaching the outer surface of the Earth as 100 units, about 35 units of energy are reflected back by the atmosphere. Look at the following table to see how the remaining 65 units of energy are distributed. Amount of energy reflected by the atmosphere and Earth's surface 35 units, direct terrestrial radiation 17 units. Energy reaching the Earth's surface 51 units, energy held by the atmosphere 14 units. So the total energy received by the atmosphere and surface of the Earth is 65 units. Radiation from the atmosphere 45, direct terrestrial radiation 17. So the total energy radiated back from the Earth's surface and atmosphere is 65 units. Now you might have understood that the entire energy reaching the Earth's surface is returned to the outer space through various means. Through this heat balancing process, termed as heat budget, the surface temperature of the Earth is kept balanced. What would happen if there was no heat balancing process? Temperature. You have learned that the Earth's surface as well as its near atmosphere is heated by insolation. Temperature is the degree of hotness of the atmosphere. It is from the weather condition at 2 p.m. that the meteorologists measure the maximum temperature of a day. The minimum temperature is taken just before the sunrise. Look at the weather information. The term maximum and minimum temperature are usages quite familiar to you since they frequently appear in the media. The difference between the maximum and the minimum temperature of a day is the diurnal range of temperature. Diurnal range of temperature is maximum temperature of a day minus the minimum temperature of the day. The average temperature of a day is termed daily mean temperature, can be calculated as daily mean temperature is equal to maximum temperature plus minimum temperature of a day by 2. Maximum minimum thermometer. This is the instrument for measuring the maximum and minimum temperature of a day. Here the two thermometers are connected using the U-shaped glass tube. The mercury filled in the maximum thermometer expands with the rise in temperature, pushes up the metal indicator. Indicator remains at position showing the maximum temperature of the day. Thus the maximum temperature can be read at any time during a day. Minimum thermometer has alcohol built above the indicator. When the temperature falls, the indicator is pushed up as the alcohol contracts. Minimum temperature can be read from the position of the indicator at any time. The temperature distribution map can be prepared based on the temperature recorded at different places. Look at the map. You can see smooth curved lines connecting the places having equal temperature. This is a method used to represent the distribution of temperature in maps. Imaginary lines connecting places having equal atmospheric temperature are called isotherms. You know that temperature varies from place to place on the Earth's surface. Let us find out the reason behind this. Thermal equator. If isotherms are plotted by connecting the places having the highest temperature on Earth, it will run almost parallel to the equator. Such an imaginary light is called thermal equator. We have studied that the sunlight is most intense in the tropical region. The region receives more energy as the sun rays are almost vertical. Angle of incidence of the sun rays become more inclined approaching, and there occurs energy loss as the same rays has to travel through the atmosphere owing to the inclination. Altitude. We have studied that the temperature in the troposphere decreases at the rate of 1 degree Celsius per 165 meter of altitude. The temperature is comparatively low at places situated much above the sea level. Nearness of sea. Examine the table showing the temperature related data of some cities in India. City Tirunelveli, maximum temperature 33 degrees Celsius, minimum 28 degrees Celsius, range of temperature 5 degrees Celsius. Bengaluru 35 degrees Celsius, minimum 23, difference is 12 degrees Celsius. Delhi 38 maximum, minimum 21 degrees Celsius, range of temperature 17 degrees Celsius. And it's go with 33 degrees Celsius, minimum 27 degrees Celsius, range of temperature is 6 degrees Celsius. Find the location of the given cities with the help of atlas. The diurnal range of temperature is very high for Delhi and Bangalore, whereas it is very low for Tirunelveli and Goa. It can be inferred that the range of temperature will be high at places away from the sea and vice versa. Temperature remains moderate at places close to the sea. This is because the heating of the land causes wind to blow from sea to land and cooling of land causes wind to blow from land to sea. Winds. Hot wind in Delhi, many sunburn. Palakkad burns hot wind from Tamil Nadu. Cold wind snowfall in the valley. Observe the new headlines. The warm and the cold winds can respectively raise or lower the temperature of the places through which they pass. Temperature of a place vary in accordance with its latitudinal location, altitude, nearness to sea, winds, etc. The smooth curved lines represent the temperature recorded at different places throughout the Earth's surface. Isotherms in the southern hemisphere are most parallel to the equator compared to those in the northern hemisphere. During summer, high temperature prevails over the land compared to the sea, and during winter the condition is reversed. Bending of isotherms is due to the differential heating of land and water. It is the fluctuation in the atmospheric temperature that lead to the atmospheric phenomena like pressure variation, wind, cloud and precipitation. Water content in the atmosphere significantly influences the atmospheric phenomena. Water in the atmosphere. Water content in the atmosphere is called humidity. List out the factors influencing the amount of moisture in the atmosphere. Temperature. Humidity varies not only with place but also with the time. Actual amount of water present in the atmosphere is called absolute humidity. It is measured as the amount of water vapor present per cubic meter volume of air. There is a limit to the amount of water vapor the atmosphere can hold at a certain temperature. The stage at which the atmosphere is fully saturated with water is termed as the saturation level. Wet and dry bulb thermometer. It consists of two thermometers. One records normal atmospheric temperature. The bulb of the second is kept wet by wrapping it in the wet muslin cloth. It is known as the wet bulb thermometer. As the bulb is wet, this thermometer always shows lower temperature than normal. Relative humidity is calculated based on the difference in temperature between these two thermometers. Based on the difference at any particular temperature, corresponding relative humidity can be found out from the chart given along with the instrument. Generally, the relative humidity will be low when the difference in temperature it is high and vice versa. Sublimation. In some instances, due to rapid fall in atmospheric temperature, water vapor directly condenses to solid state and is called sublimation. Rapid fall in atmospheric temperature. Okay. When the atmosphere becomes saturated, condensation begins. You might remember what you have learned about condensation in either classes. The critical temperature at which condensation begins is called dew point. Ratio between the amount of water vapor present in the atmosphere and the total water holding capacity of the atmosphere at a given temperature is called relative humidity. It is usually expressed in percentage. For example, if the absolute humidity is half of the total water holding capacity at a particular temperature, then the relative humidity will be 50%. Let's see how it is calculated. Relative humidity is equal to absolute humidity by total water holding capacity of the atmosphere at that particular temperature into 100. Relative humidity is measured using the instrument called wet and dry bulb thermometer. Forms of condensation. Atmosphere should reach the saturation level for condensation to begin. With the further addition of water vapor or due to a considerable fall in temperature, the water vapor in the atmosphere begins to condense. Look at the different form of condensation: for frost, cloud, mist or fog, then dew. You might have noticed that water droplets clinking on the blades of grass and leaves early in the morning. This is dew. The surface of the earth gets cooled during the night and it cools that near atmosphere. This causes the water vapor to condense and the condensed droplets cling on the cold surface of earth. Frost. As you know, there are places on the earth where the night temperature falls below 0 degrees Celsius. Instead of dew, tiny ice crystals are formed in such places. This form of condensation is called frost. Fog or mist. You might have experienced similar weather at least during winter season. It is called mist or fog. The condensed tiny droplets of water formed by the cooling of air remain suspended in the atmosphere itself. They can very well be described as clouds close to the Earth's surface. Fog or mist is the result of condensation around the minute dust particles in the lower atmosphere. This may obstruct visibility. If the range of visibility is less than 1 kilometer, it is termed fog. If the range of visibility is more than 1 kilometer, it is called mist. Airport in North India get temporarily closed during winter due to dense smog. In industrial regions, smog and fog occur in combination to cause an atmospheric condition called smog. This usually causes hindrance to traffic. Clouds. You have learned earlier that clouds are formed by the condensation of water vapor around the fine dust particles in the atmosphere. Water droplets are formed are less than 0.001 centimeter in dimension. That is why they remain suspended in the atmosphere. Haven't you seen different types of clouds in the sky? Clouds may be classified according to the form and height. Based on the form, there are mainly four types of clouds. Cirrus clouds, they are feather-like clouds in the upper atmosphere in clear weather conditions. Stratus clouds, they appear in thick layers in the lower part of the sky. Cumulus clouds, these clouds resemble huge cotton bundles and are formed due to strong convection currents. They have large vertical extent. Nimbus clouds, these are dark rain clouds in the lower atmosphere. These clouds appear dark as it does not allow sunlight to pass through due to thick concentration of water droplets. The clouds mentioned above do not generally occur independently. They are usually seen in combination. For example, the combination of cumulus and nimbus clouds are termed as cumulonimbus clouds. Above discussed clouds usually occur at different altitudes. See the four types of clouds based on altitude. High clouds 20,000 to 40,000 feet, medium clouds 7,000 to 20,000 feet, low clouds less than 7,000 feet, clouds with great vertical extent 2,000 to 30,000 feet. You have learned that clouds are formed by the condensation of water vapor. Let's see what happened to these water droplets thereafter. Precipitation. Continuous condensation causes the droplet in the clouds to grow in size. Being unable to resist the gravitational force on the earth, water droplets get released from the cloud and fall on the earth in different forms. This process is called precipitation. There are different forms of precipitation. The common manifestation of precipitation is the form of water drops. This is the rainfall. When the temperature falls below 0 degrees Celsius, precipitation reaches the earth in the form of tiny crystals of ice. This is the snowfall. If the water droplet released from the cloud happen to pass through colder layers of the atmosphere, they may reach the earth in the form of ice pellets. This form of precipitation is called hailstones. Rain occurs differently. Let's see the different types of rainfall. Look at the diagram. The moisture-laden wind from the sea enters the land and move upward along the mountain slopes where it gets cooled and condensed to form clouds. When the windward sides of the mountain receive heavy rainfall, the leeward sides do not receive rainfall due to the descending dry air. This type of rainfall is known as the orographic rainfall or relief rainfall. The places situated at the leeward side of the mountains that do not receive any rainfall are referred to as the rain shadow regions. You have learned the characteristics of equatorial climatic region. High temperature and daily afternoon rains are the peculiarities of these regions. Due to high temperature, air gets heated and rises up. Cumulus clouds are formed by the cooling and condensation of rising warm air. Rainfall occurs with the thunder and lightning. This rain, mostly occurring in the afternoon, does not last long. This type of rainfall is called conventional rainfall. It is a common phenomenon in the tropic region during summer. There is always a difference in the atmospheric temperature over land and sea. If the air over the sea comes in contact with the air over the land in the coastal regions, the warm air will be pushed upwards, causing cloud formation and rainfall. This type of rainfall is called the border rain. All the functions of our living planet, the Earth, are regulated by the Sun. The very existence of the biosphere is by direct or indirect dependence on the solar energy. Even the distribution of plants and animals on Earth is in accordance with the availability of the sunshine. The case of human beings also is not different. All the atmospheric phenomena is inevitable for sustaining life on Earth and controlled by solar energy. There is a natural mechanism to retain the required amount of energy obtained from the sun and to send back the surplus. Average surface temperature of the earth will vary with even slightest variation in the energy flows, insolation and terrestrial radiation. This in turn becomes a threat to the sustenance of life. We have learned about the human activities that can change in the atmospheric temperature. Let's control such unscientific practices and sustain our earth for the generations to come. So that's all about this chapter. If you are interested, please do like, share and subscribe my channel. Okay, thank you.